Okay, first things first, polynomials, right? Can you tell me real quick, what are the characteristics of a polynomial? What are the rules we have to follow for a polynomial? Say it again. Okay, good. So the exponents have to be a positive power. They have to be, what kind of numbers? Do you remember? Whole numbers, good. Okay. What about the coefficients? Say it again. Okay, yeah, the coefficients are going to be the numbers multiplied by the variables. Okay. What kind of numbers can they be? Negative and positive. What's the only thing they can't be? Say it again. They could be zero. If they're zero, that term just wouldn't show up. Imaginary. There you go. They have to be real. They just can't be imaginary. Good. Okay, so then you guys just tell me here, vote with your fingers, one for A, two for B, etc. Determine whether this function is a polynomial. Which one of these is, and look carefully at the answers because there's a couple of them that are similar. What do you think? Yeah, good. I'm seeing lots of threes. Good. So it's C, isn't it? This is not a polynomial. How come? Because of that. There's the red flag, right? We don't have x's in the denominators. That's not what polynomials look like. Okay, so good. Okay, how about that guy? That is a polynomial, right? So if I wanted to write that in standard form, which term comes first? There you go, 5x to the fourth, then 7x, and then finally we get the minus 3. Good. So how would you classify that then? It's the what's the degree? 4. Okay, so it's fourth degree. How many terms? 3. So what would you call that then? Quartic trinomial. There you go. Good. Good, good. All right. You guys are on top of this. Okay, thumbs up or down. Is that a polynomial? Yeah, good. It is a polynomial, isn't it? Yep, everything's fine. Okay, how about that one? Yes or no? Ooh, how come? How come, Maylin? You're right. Negative exponent. There you go. Right. There's our red flag right there. Okay. Good. How about that one? Thumbs up or down? Thumbs down. How come, Mackenzie? What's going on? There you go. The exponent's a fraction. We can't do that, can we? Perfect. So there's our red flag right there. Okay. That one's no good. How about that one? What looks weird about that, everybody? Yeah, we got a square root of, we got some kind of a weird thing going on with the variable there, right? We have a square root of x cubed. We can't do that stuff, right? The x has to be by itself to a power. Can't be inside a radical. So there's our red flag. Oops. There we go. And then how would I, if I wanted to simplify this, if I want to subtract polynomials, what would I do? Distribute the negative and then combine like terms. There we go. Did you have a suggestion? Ah, perfect. There you go. Perfect. Okay, so we would stack these things up, wouldn't we? When we distribute the negative, let's see what we get for an answer here. So what's going to be the biggest power of x? Cubes. Okay, so then what we want to do is we want to set aside columns, and you don't really have to write this down necessarily, but I'm going to do it just this time. We're going to have our x cubed column, our x squared column. We have to have a column for each power of x, starting with the biggest, right? Our x column and then our constant. And we'll just kind of put everything in those spots, right? So first we've got all this stuff, right? We've already got those terms. And I can just get rid of those parentheses, can't I, right? There's nothing being distributed there. So we're going to end up with a 5x cubed minus 6x squared plus 2x minus 4. And now we've got to do all our distribution. So I'm going to subtract 7x cubed. I'm going to subtract a negative, so that's adding, right? So we're going to add 5x squared, subtract a negative, so I add 9x, and then I subtract 10. And if I combine those, I've already got them stacked vertically. Doesn't that work out where, how many x cubes am I going to have? -2. Okay, how many x squareds? -1, good. Minus x squared. How many x's? 11. And how many, what's my constant? -14. You got it. Okay, what's the degree, everybody? 3. There you go. Okay, if I'm multiplying, same kind of thing, right? I'm just going to distribute. Now, which one should I distribute from? The 2-term polynomial or the 3-term polynomial? Yeah, it's just a good idea. Distribute from the one that has fewer terms. So again, if I add all this up, let's see, if I distribute the x, what are we going to get here? We'll just kind of here, I'll do it down here. So I'm going to get an x cubed minus 3x squared plus 3x. Now notice that those powers all went in order, but if I skip the power, what do I want to make sure I do? Well, like, let's just say I had gone from my x cubed down to my x. I want to make sure I leave space for the x squareds, right? I'm going to stack these things up vertically where I've got a column for each power of x, just like I did on the last one. Right here. In fact, let's just do this. We got our x cubes, our x squareds, our x's, and our constants. Okay, now we'll distribute the 3. So I've got a plus 3x squared. What's that? A minus 9x and a plus 9. And if I add all those things up, there's my x cubed. Well, look what happens there. Those cancel, right? Those are gone. Here I'd get, what's that going to be, everybody? Okay, good. Minus 6x and then a plus 9. Let's check ourselves. Oh, what do you know? We got it. Okay. So far, how about all that stuff we've done so far? Everybody good on all that? Okay. All right, Toese, how would I do this one? So I want to use, now I could just square this one out, right? But let's try to use our patterns. Okay. Toese, do you remember what the pattern is if I've got a binomial squared? So that's going to be this pattern, right? A plus B squared. What's our A going to be replaced by? 3x squared. What's our B going to be replaced by? -7. Okay, good. Now, what is that pattern? You guys remember? A squared. Good. This is kind of Pascal's triangle stuff, right? A squared plus, what's 2ab? There you go. And how do we know that? Because remember that, whatever the exponent is, that's always going to be the second coefficient, isn't it? So that's always going to end up there. And then if it's a row 2, right, if the exponent is 2, how many terms do I have? 3. Yep, exactly. Always one more than the exponent. What's the last term going to be? B squared. Okay, good, good. So Johnny, what's that give me then if I replace all that stuff? Instead of A, I get what squared? 3x squared, good, plus 2 times A, which you already told me was 3x squared. What's B? -7, good. And then plus B, which you already told me is -7 squared. Make sure you put all that stuff in parentheses, right? It's really easy to forget to put the parentheses there, and then that'll end up being the wrong sign. So what is 3x squared, that quantity squared? What's that going to give me, Mackenzie? If I square out that first term, what am I going to get? There you go, 9x to the 4th. Good, because remember, I have to square out both the 3 and the x squared. Good job. Okay, what's the middle one going to be? Plus 2 times 3x squared times negative 7. Negative, what's it going to be? 2 times 3 is 6. 6 times 7 is what? 42. There you go. 42, and it looks like I'm going to have an x squared. And then everybody, what's negative 7 squared? Positive 49. Okay, good. We got this. Okay, good. Give me 1 to 5. Everybody good on all that? Okay. So you're going to have one of those. You're going to have one that's a cube. So we got to remember our a plus b cubed pattern. This is good practice. Okay, 1, 3, 3, 1. Good. Coefficients. First one's always 1. Second one's going to be 3. And then you know there's going to be 4 terms, and it's got to be symmetrical, right? So 1, 3, 3, 1. There you go. Okay, so first one is a cubed. What comes after the 3? A squared b. Okay, good. A squared b to the 1 plus 3 ab squared, a to the 1 b squared plus 1 b cubed. There we go. Okay, so if we apply this pattern, oops, let's scoot this guy up a little bit. Guess we can't leave him behind. Okay, what's that going to give us? Well, what are we cubing there? What's a being replaced by? 8x. Okay, good. And you'll have a calculator for this, right? I know these are kind of big numbers. 8x cubed plus 3 times, okay, good, the quantity 8x squared times 9, okay, plus 3 times 8x times 9 squared plus 9 cubed. And those are big numbers. 8 cubed. That's 5, what is that? I can't remember off the top of my head. Yeah, 524. What is it? Yeah. 512. There you go. That's right. 512. 512x cubed plus, now this is a little tricky here, right? I've got to square out the 8 and the x. So the 8x quantity squared, that whole thing is getting replaced by what? 64x squared. Okay, that's going to be a big number. Somebody have just go ahead and jump on your phone or something and somebody crank that out real quick. What is 3 times 64 times 9? 1728. Okay. Whoops. So we get 1728. And what power of x? Squared. Good, because I'm going to have to square that x, aren't I? So x squared plus, this is now, let's see, this 9 squared is going to turn into an 81. So if they can jump back on there again, we need 3 times 8 times 81. Say it again. 1944, okay. What power of x there, everybody? 1, okay. And then 9 cubed, that's just 729. Okay, so there we go. That's our answer, right? Okay, good. All right, so now what about we got a big one like this. You're going to get one that's not very hard. It's just y minus 2. So the A's and B's are pretty simple, but it's a big power. So this is one where we have to build Pascal's triangle, right? Start at the top. How do we start? What's row 0? And I would encourage you to just write this down on your paper when you first start. You won't have access to your notes, right? You're going to have to kind of memorize this, but you can build this on right at the very beginning, just write down Pascal's triangle. So what is the 0 row? What's that look like? 1. Okay, good. Next row. 1, 1. Okay. And then 1, 2, 1. Good. And then 1. And everybody sees what we're doing. Give me thumbs on this. Everybody good with this? Yeah, everybody can build this, right? Okay, 1, 3, 3, 1. There we go. We're getting the hang of this. Okay, right? And then 6, what's that going to be? 1, 6, 15. There you go. Good. And then all we need, we'll just do these last two, I guess. We just need row 7, don't we? Right? Because we're doing y minus 2 to the 7th. So this is the row we need right there. Right? Okay, so then what's this going to give us? We can scroll down a little bit. So we're going to get 1 times what? Y to the 7th. Okay, because that's our first one, right? So we get 1 y to the 7th plus 7 y to the 6th times negative 2 to the 1 plus 21 y to the 5th times negative 2 squared plus 35 y to the 4th negative 2 cubed. Good. Plus, oh my gosh, this is a big one. 35 y cubed negative 2 to the 4th plus 21 y squared negative 2 to the 5th. Yikes. Plus 7 y to the 1 negative 2 to the 6th plus 1 times negative 2 to the 7th, right? Wow. It's a lot. So if we simplify all that stuff, what's that give us? Well, y to the 7th is our first one, right? How about this one? I've got 7y to the 6th times negative 2. What's that make the coefficient? Negative 14. Okay, good. 7 times negative 2. So that's going to give us minus 14 y to the 6th, it looks like. Now, how about this guy? We've got our negative 2 squared is what? 4. Here, while we're at it, what's negative 2 cubed? Positive or negative? Negative. Good, because it's an odd power. Good. So minus 8, negative 2 to the 4th. 16. Good. I'm just multiplying each of these last ones by negative 2, aren't I? So that becomes positive 16, negative 2 to the 5th, negative 32, negative 2 to the 6th, positive 64, and finally negative 2 to the 7th would just be negative 2 times 64. So 128. Yeah, okay, good. So now if we multiply all this stuff out, so we're on to this term right here, right? That's going to be positive, isn't it? 21 times 4, what's that? 84? 84 y to the 5th plus, let's see, 35 times 8. Well, I'm just going to get minus, aren't I? So I get minus 35 times 8. That just means I'm going to double 35, get 70, double it again, get 140 to get, and then double it again, right? So 280. 280 y to the 4th. And then this one right here is going to be plus 35 times 16. Well, isn't that just 35 times 8 times 2? So it's going to be twice as big as that, 560. And you have a calculator too. 560 y cubed. And then here we're going to have, so that's this guy. Let's kind of keep track. That's that guy. How about this one? We get negative 32 times 21. So that's going to be 640 plus 32. So 672 minus 672y squared. And then what do we get here? 7 times 64. So that's going to be 420 plus 28, 448 plus 448y. And then finally, minus 128. Well, I don't know that I did all my mental math right here. I guess we'll see if I did. Those numbers look right. Oh, 670. Yeah, I guess I did. Okay, good enough. All right. And again, you got a calculator for doing all the computations. Okay, good. Makes sense? That's a long one, right? But it's really not that hard. It's really not that big a deal. You just got to make sure you draw out Pascal's triangle for that one. Okay, end behavior. Now, which term up there is going to be the one that determines the end behavior? Yeah, the one that gives you the degree. So which one is that? Which is the important term that's going to give us the end behavior? Okay, good. Now notice this polynomial is not written correctly, is it? It's not written in standard form. If it were written correctly, that would be my leading term, wouldn't it? Okay, so how would you describe that end behavior then? Yeah, good. Okay, negative, even. Perfect. So we get negative, even, which we know looks like, everybody do it with your arms. What's negative, even? Yeah, it's that, isn't it? So that's right here, isn't it? Looks like B. Okay, boom. Okay, how about that one? What's my end behavior going to be? Negative, odd. Okay, so vote with your fingers. 1 for A, 2 for B. Which one's that going to be? Yeah, good. It's going to be negative, odd. What's that going to be? There you go. Good. Good. What's it going to be? Everybody show me fingers on this. Yeah, good. 3, isn't it? Good. It's going to be C. Perfect. All right. I'm thinking this is looking pretty good. How about that one? What's that going to be? Which one? A, B, C, or D? Vote with your fingers. Yeah, 3 again, isn't it? That's positive odd. Good. Good. And then finally, what's that one? Yeah, positive even. Good. So D. All right. Good stuff. We might as well just finish this up, and you guys can have tomorrow another prep day. Okay? We're getting so close here. So what's the leading term of that polynomial? The leading term. There you go. It's the first term, right? So negative 1/3 x to the 4th, which makes the leading coefficient negative 1/3. The degree, show me with your fingers, everybody. 4, perfect. So what do we call it if it's 4? Quartic. Okay, and that'll just be a pull-down menu you can choose from. Okay, how about this function? What's the degree? 7. So what's the maximum number of real zeros? 7. There you go. Which means that the maximum number of x-intercepts is 7. Okay. Maximum number of turning points? 6. Man, you guys have got this stuff. This is easy, huh? So now I gave you a graph. Show me with your fingers here. How many turning points does the graph have? Yeah, 4. Good. It's got 4 turning points. Okay, so what is that telling us? That piece of information, that clue tells us that the minimum degree is what? N has to be greater than or equal to, if that's number of turning points. I think I heard it. It's got to be 5, right? Remember the number of turning points? can at the very most, so if the number of turning points is 4, that means that the degree has to be at least 1 bigger than that, right? That makes sense? Because if it's an nth degree polynomial, the biggest number of turning points you could have is n minus 1, okay? So that's telling us 5. How about the number of x-intercepts? How many do you see? 5, okay? And they actually want them, so there's 5 of them there, right? So what is that telling us then? That's giving us the clue, and that's telling us that n has to be at least what if we have 5 x-intercepts? Could be more than that. If the degree of a polynomial is n, what's the biggest number of x-intercepts it could have? You guys already told me. Let's go back to the last slide. Think about this. The degree was 7, so it could have at most 7, right? Does that make sense? Okay, so then now, if we have 5 x-intercepts, then it could be, the degree could be really big, right? But the smallest it could be would be what? 5, yeah. Couldn't be any less, right? Because if the degree were 3, it couldn't have 5 x-intercepts, right? If the degree were 3, what's the most it could have? 3, yeah. So it's got to be at least 5, doesn't it? Okay, is A positive? Thumbs up for positive, thumbs down for negative. Yeah, because what kind of behavior is this n behavior? Positive odd, isn't it, right? If we ignore the middle, it's doing this, right? Positive odd. So we know it's positive. And then what if we assemble all those clues? First clue said it's got to be at least 5, the degree. Second one says it's got to be at least 5. This is an odd degree polynomial, right? So it's 5, isn't it? The minimum degree is 5. It's got to be at least 5. Could be way bigger than that, but that's the smallest it could be and have all that behavior. Okay, give me 1 to 5 on that one. That one's, there's a lot of stuff going on there, right? Okay, last one. Last one here. So we want to come up with a sketch of this. That's the whole point of this one. So the two things we need here are n behavior, and we need to know what's happening at the x-intercepts. That's it, right? So let's do n behavior. Can anybody tell me what the leading term is going to be? Negative 1/2 x, no? Okay, let's look at it. So now if I want to get the leading term, I'm just going to multiply the number outside times each of the leading terms of those factors, right? So this one is already done, right? I've got negative 1/2, I'm going to multiply times x. But what about the x minus 3 squared? If I were to, I'd have to expand that out, right? If I were going to write out this whole polynomial, the whole thing, I would have to take that x minus 3 and expand it out and then distribute, right? All I care about is the first term, though. What's the first term of that red expression going to be when I multiply it out? X squared. There you go. So I know I'm going to get x squared plus a bunch of stuff. And then the other one is just x plus 1. Okay, so what are the things I'm multiplying then? Negative 1/2 times x squared times another x. Well, what are those? What's the power of x going to be? What's x times x squared times x? X to the 4th. There you go. So I'm just going to get a negative 1/2 times x to the 4th, right? So then that's my eventual polynomial is negative 1/2 x to the 4th plus a bunch of other junk we don't care about, right? That's the leading term. How would you describe that n behavior? Yeah, that's negative even, isn't it? So we're doing this, right? So there's my n behavior. Okay, now what about the zeros? Right? This whole thing, I have to know when the whole thing is equal to 0. Right? When does g of x or when does y equal 0? Well, what are the values of x that would make that happen by the zero product property? The only way I could multiply those 4 things together and get 0 is if I'm multiplying by 0. Well, the negative 1/2 is net. That one's not going to give us any answers, is it? That's just a constant. That's just a number. But the blue factor could equal 0 when x equals what? -4. So there's one of our zeros, right? -4. Okay, and so we could even put an x-intercept at -4 right there. Okay, what's the red x-intercept? 3. Okay, good. So we can put an x-intercept at 3. And what's the green x-intercept? -1. Okay, so now we've got a green x-intercept at -1. We just need to know what's going on at each of those intercepts based on the multiplicity. So what's the multiplicity of -4? 1. How come? Okay, because that factor has a power of 1. Everybody see that? Okay, so the multiplicity there is 1, which means what's the behavior of the x-intercept? It's going to cut like a line. There you go. Okay, so we know that. That cuts like a line. What about the 0 at x equals 3? Show them with your fingers. What's the multiplicity? Good, 2. Look, I've got it squared up there, don't I? So what's that one going to do? It's going to bounce. Good. And then finally at -1, the multiplicity is 1. So again, I'm cutting like a line. So that's all we need, isn't it? If I know what my end behavior is, if I start at the left, it decreases to the left, doesn't it? So we know that the function has to finish, like this on the left. And we know it's going to cut through the x-axis at -5, so it's going to go through. It's going to cut at -1, so it's going to go through again. And what's it doing at 3? It's bouncing, so it's going to bounce. Ooh, yikes. Get my knuckles in there. And then it finishes down there like it's supposed to. That's it. Okay, makes sense? So now your job, we're just going to take our sketch, which you can do. I've got that excellent graph paper up there. We're just going to take our sketch, take a little picture of our beautiful sketch here. And we just have to figure out which of these matches it. Okay, well, you guys show me which one seems to match. The second one, okay, so I guess that one right there looks good to me, right? Everybody agree? That's our winner. Right here. There it is. Okay, give me thumbs. Man, you guys, I think you guys got this. I do. Got another day, finish up those practice tests, work away on this stuff. We are good. Yes, you may.